Hello everyone, how is your day? This is your tutor, Orekoya Olusegun Physics Mathematics Fundamentals on YouTube. Please do not forget to like, share, subscribe and click on the bell button to have more of my video. Today we are taking a topic in mathematics, and that topic is how to derive what is called Euler's constant. In mathematics, Euler's constant is a very useful constant in mathematics, and we normally use symbol E to represent that constant. Please, before we go further, I will refer you to my other video where I introduce the concept of a polynomial function as a series, then where I generated what is called Maclaurin's and Taylor series. That will be, this particular solution is a continuation of that topic. Please kindly click on my other video to check on those topics so that you can be able to comprehend what we are having here. Now, to solve this problem, we are going to use Maclaurin series, and Maclaurin series is f of x is equal to f of 0, 0, 0 factorial s raised to power 0 plus f prime of 0 s raised to power 1 over 1 factorial plus f prime prime of 0 x raised to power 2 over 2 factorial plus f prime 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 of 0 s raised to power 3 all over 3 factorial plus f fourth derivative of 0 all over 4 factorial x raised to power 4, and so on, plus and so on and so forth. This is what is called Maclaurin's series. So I can rearrange this series, rewrite this in this format. F of 0 actually means the same function. S raised to power 0 is 1, 0 factorial is 1. So what we have here is simply f of 0, then plus f prime 0 of x, because 1 factorial is 1, x raised to power 1 is x, then plus f prime prime 0 x raised to power 2 all over 2 factorial plus f prime 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 of 0 x raised to power 3 all over 3 factorial plus fourth derivative of the function, then times x raised to power 4 plus and so on and so forth. Now, for us to find this constant E, let f of x become e raised to power x, which is this now, f of 0 plus f prime of 0 x plus f prime prime of 0 x raised to power 2 all over 2 factorial plus f prime 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 of 0 x raised to power 3 all over 3 factorial plus f of 0 the fourth derivative of the function f at point 0 divided by 4 factorial, then x raised to power 4 plus dot 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 dot. So that means this pattern continue that way. Now we need to find expression for f of 0, f prime of 0, and so on and so forth. Now we have f of x to be e raised to power x. Therefore f prime of x is still in a standard differentiation. Differentiation of exponential function remain as it is. So that means f prime prime of x again, that means you find derivative for this again, is still the same thing, and so on and so forth. The derivative of the exponential function remain as exponential function. Now when the value of our x is equal to 0, that means each of these one now become f of 0 is equal to e raised to power 0, which is 1. This one also become f prime of 0, which is e raised to power 0, which is equal to 1. That means whatever I have here is always equal to 1. That means all my derivative that I'm having here is equal to 1. So that means my e raised to power x now, can be written as f of 0 plus, instead of f prime of 0 is 1, so I will just write it as x, then plus this one too is 1, so times x squared divided by this, so I have x squared all over 2 factorial plus this one I have here will be x raised to power 3 all over 3 factorial plus this one will be x raised to power 4 all over 4 factorial plus the pattern continue as s raised to power 5 all over 5 factorial plus s raised to power 6 over 6 factorial plus s raised to power 7 over 7 factorial plus, then you continue here, s raised to power 8 all over 8 factorial plus s raised to power 9 over 9 factorial plus. This continue like that. Now here I'm talking about f raised to power 0. Since f of x is this, f raised to power 0 is 1, so that means this one is 1. So my e raised to power x now is written as 1 plus x plus s squared all over 2 factorial plus s cubed all over 3 factorial plus s raised to power 4 over 4 factorial plus s raised to power 5 over 5 factorial over 5 factorial plus s raised to power 6 over 6 factorial plus s raised to power 7 over 7 factorial plus s raised to power 8 over 8 factorial plus s raised to power 9 over 9 factorial plus, and so on and so forth. I intentionally extend the summation of my terms to up to the 10th times here. The reason why I did that is to be able to have a better approximation. Now we want to get an expression for e. E simply means power 1. So in this case now, my x here 1 will be 1. So that means the expression that I have here, I'll write it as s raised to power 1 is equal to 1 plus 1, then plus 1 square is 1. So I have 1 all over 2 factorial plus this one will be 1 all over 3 factorial plus this one will be 1 all over 4 factorial because all my x are 1 already. Then plus 1 all over 5 factorial plus 1 over 6 factorial plus 1 over 7 factorial plus 1 over 8 factorial plus 1 over 9 factorial plus the pattern continue like that. So here now 1 plus 1 is 2. So it's going to be 2 plus everything that I have here. When you use your calculator to evaluate 1 over 2 factorial, you add it to these other terms. Our final answer will now be e is equal to 2 plus whatever we have here after pressing this calculator. And by virtue of pressing the calculator, I have my e approximately equal to 2.182 2.72818. So this is the value for the Euler's constant. I believe that you must have been able to observe how we derive Euler's constant from the foundation of our knowledge as regards Maclaurin series. Once again, this is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please do not forget to share my video. Please share my video on Instagram, share my video on WhatsApp, share my video on X Andrew, which is formerly known as Twitter. Share my video on Telegram. Share my video on all social media so that it can be able to reach to targeted audience. The audience can be your family members, can be your co-workers, children, can be anybody or any place all over the world. This is your committed tutor. Thank you so much for having you. Have a nice day. Bye.